A thin rod of length L is lying along the x-axis with its ends at x equal to 0 and x equal to L. Right, this is a rod. It is lying at x equal to 0 and the other end is at x equal to L. Right, its linear density lambda, which is mass per unit length, varies as k into x by L whole raised to power n, where n can be 0 or any positive number. If the position of x center of mass of the rod is plotted against n, which of the following graphs best approximates the dependence of x center of mass on n? Right, now for calculating the x center of mass, what is happening generally, if this was a uniform rod, its center of mass would have been at L by 2, but its linear density is changing, right? So that means x center of mass is given by x into dm divided by integration of dm, right? So if I'm talking about dm, what is dm basically? Dm will be equal to lambda into dx, right? So that means it implies that x center of mass will be given by integration of x into lambda. Lambda is where kx raised to power of n divided by L raised to power of n into dx divided by integration of kx raised to power n divided by of L raised to power n into dx, right? So this will be we can take out k by L raised to power n as common, so which will cancel out from the numerator and denominator. This will cancel out because these are constants basically. So this will be integration of x raised to power of n plus 1 into dx divided by of x raised to power of n into dx, right? So this will be equal to basically, this will be integrated from 0 to L, this will also be integrated from 0 to L. It will be x raised to power n by n plus 2 divided by of n plus 2, and we will put the limits above as 0 to L, and denominator will be x raised to power of n plus 1, and the limits will be from 0 to L divided by of n plus 1, right? So if we put the limits, we'll get n plus 1 divided by n plus 2, we'll get L raised to power of n plus 2 divided by L raised to power of n plus 1, right? So which will be equal to n plus 1 divided by of n plus 2 into L. So this is basically the formula that we are getting for x center of mass, right? So if we draw the graph, we can again simplify this. Let us simplify over here. X center of mass can be written as L into I can write it as n plus 2 minus 1, right? So n plus 2 divided by n plus 2, 1 minus 1 upon n plus 2, right? Right. So we get this formula. Now if we put n equal to 0, what we will get? We'll get x center of mass as 1 by 2 into L, right? That means we can eliminate the option C, because at n equal to 0 it is showing L, right? So that means we have to choose between A, B or D, right? Now what if n becomes infinity? If n becomes infinity, this term will become 0. That means x will tends to L only, right? So that means option B can also be eliminated because it is showing a constant, thing. So that means this is eliminated. Now we have to choose between A and D. But over here we see that in D it is given that after some time it starts to increase, right? After some time x center of mass will start to increase. But no, over here what we can see, if I put n equal to 1, I'll get 2L by 3. Okay? So if I put n equal to 1, I'll get L equal x center of mass as 2L by 3. So that means which is basically higher than that. That means option D can also be eliminated. That means option A is correct.